Hey guys, we are on Unit 9, Day 7. We're going to talk about complex numbers, okay? So all numbers fall into a very broad category known as complex numbers. Complex numbers can always be thought of as a combination of a real number with an imaginary number. And they call that A plus BI form, where A is the real number, and because B has an I next to it, the BI makes it imaginary, but the B itself is a real number. Okay. We say that A is the real part of the number and that BI is the imaginary part of the number. These two parts, real and imaginary, cannot be combined. They're not like terms. Okay. And so we leave them separate like that, leaving the real part first and the imaginary part second. Okay. So in number 1, it says perform the operation and express your answer in A plus BI form. And right now we have to make sure that we notice our operation is just adding. And so when we add those parentheses that these two complex numbers are grouped in, they don't matter. Okay. If that was a minus sign that I circled, well, then we would have to distribute it like in number 2. Okay. So without parentheses, we'll just go ahead and combine the real parts, which is -2 plus 6, which is 4. And then the imaginary parts, which is 7i plus 2i, which is positive 9i. And we added two complex numbers together to get a complex number. Okay. In number 2, we got to realize we got a minus sign here. And so when we subtract, we have to make sure we subtract all the terms after it. And so we have to distribute. So 5 plus 3i stays, but then this becomes a -2 and then a plus 7i. Okay. And now it just becomes like what we just did. We'll take our real parts, which is 5 minus 2, which is positive 3. And 3i plus 7i is a positive 10i. And there's our complex number, okay? Called complex because it's made up of part real, part imaginary. All right. Number 3 says subtract that from that. And so we have to remember that this, if that's being subtracted, comes after this. Okay. And because it's more than one term, we should make sure that it's in parentheses. Okay. And so now we have -3 plus 5i subtracting -8 plus 2i. All right. And so now that just becomes what we had in number 2. We have to watch out and distribute that negative. So the -3 plus 5i will stay. And then we will have a distribute, and we're going to get a +8 and a -2i. And now it just becomes like the last couple problems. We'll take our real parts, which is -3 plus 8, which is 5. And then 5i minus 2i is a positive 3i. And there's our complex number. Okay. Heading down. Number 4 says, which of the following represents the sum of these two complex numbers? And what's different about these ones is that they have radicals with negatives underneath them. And on day 6, we learned how to simplify those. Okay, so we're going to go ahead and remember that this is actually the square root of 4 and the square root of -1, which then becomes 2i. So we're going to rewrite this as 6 plus 2i. Okay, because they said sum, we're going to add the other one together, which means we don't need the parentheses. Okay, but we need to go ahead and simplify our square root of -25. So we're going to simplify it into 25 and -1, and this is going to become the 5, and this is going to become the I. Okay, and so we're going to have the -8 here. We'll have the minus sign here, and then we said that this simplifies to 5i. It now just like becomes what we had up above. All right. We'll take our real numbers, which is 6 and -8, and combine them to get -2. And then 2i minus 5i is -3i. And now we're going to look for -2 minus 3i, which is choice 2. Okay. Oops. Okay. In the next part here, number 5, it says find the following products and express your answers in simplest A plus BI form. And so now this isn't adding or subtracting in between the parentheses or the complex numbers. It is multiplication since there's no operation written. Okay. And so we know that with binomials, we have to go ahead and put them together. And with these ones, they might actually be easier to put together with the box. So maybe we'll go ahead and draw the box for each one. And we're going to have -2 plus 6i across the top and 3 minus 2i on the bottom or on the side there. And it doesn't matter which one's which. Okay, and we'll go ahead and put them together. So 3 times negative 2 is negative 6, okay, plus 18i. Here we're going to have a positive 4i, and here we're going to have a negative 12i squared. Okay, and so we'll go ahead and simplify. One difference that we're not used to is that normally with an x squared, when we have x as our variable, we leave it x squared. But with i's, they can be simplified down, and I squared, if you remember your iCloud, is actually equal to negative 1. And so we're going to replace this with a negative 1. And so this box here becomes negative 12 times negative 1, which is actually positive 12. Okay, so we'll do all that in the box there. And you might want to make your box a little bit bigger for when we distribute two binomials with i's in them. Okay, so here we go. So basically now we got a negative 6 here plus a 12 here, which is positive 6. And then in this diagonal, we have 4i plus 18i, which is positive 22i. And there we have it. There's our complex number in simplest a plus bi form. Okay. All right, so let's try the next one. So again, maybe we make our box a little bit bigger because we have that work to do with the I squared if we get one. Okay, so we have 4 plus I across the top, and then we have a negative 5 minus 3i along the side. Okay, we'll go ahead and fill it in. Negative 5 times 4 is negative 20. Negative 5 times I is negative 5i. Negative 3i times 4 is negative 12i. And then negative 3i times I is negative 3i squared. And there's that I squared again. So we have to remember to turn it in for a negative 1. Okay? And then we have negative 3 times negative 1, which is positive 3. Okay? And now we'll go ahead and combine our real numbers. Okay? Negative 20 plus 3 is negative 17. And then we have negative 12i minus 5i, which is negative 17i. And there is our complex number. Okay. All right, last one, kind of like in number 4, we had to simplify those radicals before we can do any math with them. Okay, so going back up here, that is the same as the square root of 64 and the square root of negative 1. Square root of 64 is going to become 8, and the square root of negative 1 is going to become I. And so we end up with 2 plus 8i times 7 minus, and we're going to have to do the same thing. Nice thing is these are perfect, so they're not too hard to simplify. But that's going to become 4i. And those have to be simplified first before you go ahead and distribute. Some people will go ahead and distribute and we'll end up with the wrong answer, okay? So we have to make sure that our imaginaries, okay, or our radicals with negatives underneath are simplified to our imaginaries. Okay? All right, so we'll put 2 plus 8i across the top, and we'll put 7 minus 4i along the side. Okay, and now we can go ahead and fill it in. 7 times 2 is 14. 7 times 8i is 56i. Negative 4i times 2 is negative 8i. And negative 4i times 8i is negative 32i squared. And there's that I squared again. So we're going to make sure we turn it in for a negative 1. And so now this box says negative 32 times negative 1, which is positive 32. Okay. And we'll grab our reals, which is 14 and 32. And when we add 14 and 32 together, we get 46. And then we have our negative 8i plus our 56i, which is positive 48i. My pen's not working. Here we go. Okay. All right. So let's go ahead and go down. And we got one more on the side. And then we will go to the back side of our notes. Number 8 says simplify xi times I minus 7i all squared, where I is the imaginary unit. Okay. All right. So this is what they want me to simplify. So the very first thing to make this a little bit easier is that in those parentheses, I minus 7i will go together and it won't be a binomial anymore, which will be easier to do. Okay. So we'll go ahead and do xi and we'll leave that. In parentheses, I minus 7i, according to PEMDAS, what's in parentheses should go first. And because those terms are combinable, we'll go ahead and combine them. I minus 7i is negative 6i. We'll keep the squared on the outside. Okay. When we square negative 6i, all that means is negative 6i times itself, negative 6i. Okay. Negative 6 times negative 6 is positive 36, and I times I is I squared. Okay. Except I squared, we know from up above that we turn I squareds in for negative ones, and 36 times negative 1 is negative 36. So now we can come back. We'll keep the xi here, and we'll multiply it by negative 36. And we're just going to rearrange this a little bit and put the coefficient out in front and do negative 36xi. And there's our final answer. Okay. All right, guys, I'll see you guys on the back side of notes.